Hello friends, good afternoon and welcome to EduSet Live Lectures. Dear friends, today in Computer Sciences, we will talk about the concept of ubiquitous computing. To discuss this topic, we have with us our subject expert, Mr. Anil Kumar Mishra. Mr. Mishra is Associate Professor in Department of Computer Science in a prominent university in NCR of Delhi. Without further ado, I would like to welcome Sir to our studios and request him to start the lecture. Welcome, Sir.
Thank you, ma'am. So today the topic for the discussion would be ubiquitous computing. So the dictionary meaning of ubiquitous is everywhere, anywhere. So the topic for the discussion is what are the trends in computing and how it has been changed, what is all about ubiquitous computing, comparisons of similar technology which seems like ubiquitous, some case studies or the research application from the ubiquitous area, what are the challenges, issues, policies with respect to ubiquitous computing, and then we will conclude the session. So the first is what are the major trends in computing. So these days we are in the third or the fourth paradigm of computation. Someone say it third, someone say it fourth, but generally we will say it third. So initially we had the mainframe computer, then that is called the mainframe era of computation, then the personal computer era came, then the ubiquitous era of computation is in existence. So the ubiquitous computing, mobile computing, they are more or less same, and the pervasive computing, they are near. So in the mainframe computation, we used to had only one computer and many people used to go to that computer for computation. So computer used to be at one place and the people used to go to the computer for their computation. So the relationship was one to many. So the computer was not movable, not mobile, and but different or the various people used to come to the computer. Then the era of personal computer came, and in that case every people had one computer. For every person there used to be one computer, and every people was free to use the computer in his or her way. Then the era of ubiquitous computing came. For one person many computers are in existence. So you can see up to 1970 the era of mainframe computation was in existence, then it started declining. Then after that the era of personal computer came, and till date it is in existence, but the popularity of using personal computer is declining day by day. And after 2000, after 98, 99, and the growth in the ubiquitous computing is on its proper way. So it can be clearly seen that in the phase 1 of the computation we had one person for many computers, and the changes in the operating system and the user interface was required. The network was in the nasty stage. The wireless technology was in starting stage. Then microprocessor cost / performance ratio was very low, and the display unit was in the growing phase. Then the area, then the second phase of computation came, in which the invisible path of computation started. The tablets, pads and boards was in initial stage, and all the prototype models and all the existing models were not properly, the result of the usage was not as per the need. Then the ubiquitous computing came into the picture. So it is a concept of software engineering or computer science where the computer is made to appear everywhere and anywhere, and it is in contrast to the desktop computing, where in desktop computing it is very difficult to find out the location, time or the format. But wherever you are in the ubiquitous computing paradigm, your location, time, identity and any other parameters which should be known, it can be known immediately. Means the ubiquitous computation is context aware, the sensor network is in extensive use, and you cannot imagine the uses of ubiquitous computing without the introduction of or extensive use of artificial intelligence and the human computer interfaces. So it seems, because earlier we had the distributed computer system in the era of personal computation, but in distributed computation what we do, we fragment the workload of one computer on many computers, but which is not done in the case of ubiquitous computation. In ubiquitous computation, the main objective is to make every device invisible. So even if you are using 100 computers and you are getting result through 100 computers and you are processing 100 computers, but though most of the computers would be invisible through the user. So user would not be able to directly interact or directly know about the small computers or the component computers which is being used. And every devices, every devices, anything which is involved in computation, that is known as a computer in the field of ubiquitous computing. So you can say it is a concept of software engineering and computer science where computing is made to appear anytime and anywhere. It can occur by using any devices in any location or in any format. So elements of the ubiquitous computers are first the ubiquitousness and the pervasiveness. So lots of devices are needed for the computation to be made ubiquity, and the devices should be properly connected. So many heterogeneous types of networks are needed. So there should be flow among the networks, then context aware systems are needed. So whatever devices are being used, and context means the interactions with the environment. Though devices should be aware with the environments, and immediately all the informations needed should be captured. For example, we can have dust sensors to capture the dust volume, we can have humidity sensors to capture the percentage of humidity, we can have the temperature sensors to capture the temperature, and we can have many types of sensors which can sense the environment, and also these sensors or these context aware devices must be invisible. Means user are capturing those informations which are inevitable, which are needed in the computations, but they are not aware with that. So basically the goal of the ubiquitous computation is it will enhance the computer use by making many computers available throughout the physical environment, but making them effectively invisible to the user. The immerses computers in a real environment, sensor supports are must, and sensor should control the environment also, as well as it should be able to give the proper information. Though the power supply should be low or the limited, because 24/7 hours these systems would be in running mode, and the low memory storage or the bandwidths are needed, and the total system should be operational without giving much attention. So where even if this should be self-sustainable system, if there is some troubleshooting needed, it should be immediately signaled and immediately taken control of, and devices should be mobile and it should be wireless. And most of the devices should be wearable also, in the form of watches, in the form of radios, in the form of smartphones or the mobile phones, etc. So the ubiquity is a characteristics. Ubiquity of the system can be defined only when you are able to locate the system from anywhere, anytime, or immediately adaptation with the system is done. And of course, the system should be intuitive, transparent, and the interfaces should look like natural interfaces. Even if it is the man-made interfaces, but the user of the system should not be able to locate the fabrication or the artificial things introduced in that. So, in one line, this graph will tell you about in the first phase of computation, the mobility was very low. In the era of mainframe computer, the shifting of the computer was not possible. The computer was used to be very high weight and the high volume, and the embeddedness was 0. Then from that phase, the research went on to increase the level of mobility. On the x-axis you can say the level of mobility, and research went on also in the area of embeddedness to increase the embeddedness of the computing devices. So, in some areas if the embeddedness was high and the level of mobility was low, that area is known as pervasive computing, and even the powerful paradigm or the powerful era of computation. And in one area the embeddedness was low, but the level of mobility was high, and that was mobile computing. But these days, as per the need, the research went on, or it is the need of the systems, because the adequate number of growth has taken place in the area of computation. So, these days we also need high level of mobility and the high level of embeddedness. Lots of devices, sensors, and the context aware systems are available, which are very, very embedded in nature, and powerful context aware systems are coming daily by daily, and the mobility of the network as well as the computer devices, smartphones are increasing day by day, and accordingly the businesses are also being mobile. So, in the ubiquitous computation, the embeddedness should be of very high, and as well as the level of mobility should be high. So, such systems, if any company is fabricating, that would come under ubiquitous computation. And if any system is able to compute the problem of high mobility, and it is supporting the problem or the computation which is supporting the mobility as well as the embeddedness, that will come under the ubiquitous area. So, we can say in the older generation of computation, we can compare the older generation of computation and the new generation of computation through these slides. So, you can clearly see from one computer to many computer, then the area of one-to-one computer, then the area of many computers for everyone it came, and these systems can be used anywhere, anytime, any devices, any network, or any data. So, anything can be possible or it can be accessed. So, all the technologies, whether they are heterogeneous technology and the homogeneous technologies, they can be synchronized, they can be connected, and technologies are available for that. So, just for example of context aware system, we are taking the example of Apple phone. In the Apple phone, suppose it is not context aware, then the user interface would be natural, gesture would be simple, and it will only allow the function zoom in, zoom out, because the physical touch or the inertia is necessary to touch the icons, and it will display some result. But suppose these days the Apple phones are context aware. Context aware means, in this case, the user interface orientation would change, and if you will change the location or the angle of the mobile phone, the interface would change, and it is light aware also. Light aware means if the intensity of the light is changing, then the user interface is changing. Immediately it is capturing the information of the light, or it is capturing the information of the orientation, and it is changing accordingly. And when you are making some call through the Apple phone or you are getting some call through the Apple phone, immediately the sensors are there that is sensing the call and that is immediately stopping the normal execution of the phone, and it is giving the incoming call and the outgoing call on the priority basis. So, automatic switching is done. So, capturing the information whether the incoming phone is coming, or it will capture the information whether some call is being made, and it will stop the normal execution. This is possible only through because the phone is able to aware the context. So, we have taken 3 examples. In one example, the physical orientation is being captured, the angle is being captured, and in another example the light, intensity of the light is being captured, and in the third example whether the outgoing call information or the incoming call information is being captured. So, this device, that is a smartphone, is a device, but there are 3 sensors. Similarly, we can have many sensors inside a smartphone and powerful sensors, or as the introduction of the new sensors you can change the device with the updated sensors like that. So, the Mark Weiser, he is the father of the ubiquitous computing. His idea was you can call any system as ubiquitous, any computation as ubiquitous only if it is allowing a computer should be so embedded, so fitting, so natural that people can use it even without thinking a single line about it. Means then the system would be purely ubiquitous, and all the research has been made to make the system ubiquitous, and this can be known through the parameter that is called ubiquity. So, for any system to be made ubiquitous, the ubiquity should be quantified, and there are 3 components: how many mobile devices are being used and they are connected, how many instruments have been used by the person which are context aware, and how many devices has been used in the surrounding which are able to capture all type of context aware informations. So, as the number of mobile devices, number of networks, and the number of instruments used by the person, and the number of physical devices surrounding the network, they should be located, but a user should not be aware with all these things. Then you can say the ubiquity level is high. It seems that many things they are similar to ubiquitous, but in real sense it is not. So, it is not a science fiction, but it looks कि ubiquitous computation is like a science fiction, and it is not impossible to implement the ubiquitous computation or ubiquitous computing, and there is difference between the ubiquitous computation and the virtual reality, and it is not the personal digital assistant, and it is not the personal agent also. So, you can see that the difference between the virtual reality and the ubiquitous computation. In the virtual reality, there is one computer, and that computer has created environments virtually. Basically, one computer is being used, and that computers had fragmented its works, and it has created its environment surrounding, and only one computer is, and you cannot change that surrounding. You cannot go out of that surrounding. This is called the virtual reality. Means computer has created its environment virtually, and it is being used in that area with the connected devices. But in the case of ubiquitous computation, all the devices are real. Different heterogeneous types of devices are being used. Some are used for network, some are used for capturing information, some are used for computation, some are used for performance, etc., etc. And the changes, if one device is corrupt or is not working properly, then simply by changing that the network will properly function, or it will not hamper the network, which is not possible in the case of virtual reality. In the virtual reality, if one device is damaged, it will damage the network, it will damage the whole system. And in the case of ubiquitous computing, if one device is being damaged, the performance of the system or the computation will not be hampered, or it can be diagnosed immediately also. So, there are some features of the ubiquitous computing. Those features are very, very necessary for any system, for any software or the hardware to be part of ubiquitous computing or to the part of ubiquitous design or the system. So, the first feature is invisibility. The invisibility means the devices should be intelligent devices and it should be indivisible. The devices should be wearable. The devices should be like RFID, which is extensively used these days. It should be smart card, sensors, it can be information artifacts or any tiny smart devices. The other is context awareness and the adaptation. Though with the changes in the environment, the devices should be such that immediately it should sense or adapt the environment. And so, for that we have autonomous sensors, environment adapter, real time devices, adapting to devices, to capture the time we have devices, to capture the location we have devices, to capture the temperature we have devices, and for recording the weather we have devices. So, these devices can be used in the computation without being aware of the user. So, in the traditional area of software development or the system development or the system design, we have used the traditional process model, as example waterfall process model, proactive process model, rapid application development process model, spiral process model, etc. So, that cannot be used in the area of ubiquitous computing. So, only one process model which is being used in the area of ubiquitous computing is agile process model. So, there are many agile process model, but amongst them two process model is extensively used in the case of ubiquitous computing. So, Agile manifesto is being referred for the ubiquitous computing for the software development part. So, here individual and interactions would be given more emphasis rather than the process and the tools, and the working software is extensively used rather than the comprehensive documentation. Though customer collaboration is necessary, the customer and the developer are the part of team, whether they are the hardware developer, hardware designer or the software developer, and the incorporation of changes should be immediate. So, no planning documents are necessary. So, amongst other agile process model, two are extensively used in the case of ubiquitous computing. One is extreme programming and another is Scrum. So, in the extreme programming process, what is done? First, the user stories. So, the work is captured in the form of stories. They are prioritized value wise. Suppose there are 100 stories to be created, 100 work to be done. So, they would be prioritized value wise 0, 1, 2 up to 100. Then the acceptance testing criteria would be immediately decided there itself, and the number of iteration plan should be pre-assumed that in how many iterations these stories should be cleared. Suppose the iteration plan is 10, it means 100 stories has to be cleared, has to be sorted out, has to be delivered to the customer in 10 iteration. After 10 iteration, if any story is left, that would be a deviation. Then proper designs, short designs are created in the form of simple design and in the form of spike solution prototype design. Then the style of coding is entirely changed as you do in the case of, it is not done as you do in the case of conventional process model. So, it is done as refactoring. Refactoring is a concept that without touching the code, you are changing the code, means you are not hampering the normal execution of the software or the system, and you are changing the code. So, you are refactoring, means software does not understand that its code has been changed, its design has been changed, anything can be refactored without touching it. And the area of pair programming means too many persons are working on the same code simultaneously. A very high level of expertise are needed, and continuous integration is done, means continuous integration is done in the coding style of extreme programming. Then unit testing is done, and acceptance testing, which has been decided at the time of planning, that is verified, validated, and after the validation the software, the next stories are taken up, the project velocity is decided. Velocity means if the team could clear 80 out of 100 stories, then the velocity would be 80%. Then similarly, we have the Scrum, a very popular paradigm in the computation, which is extensively used in the case of ubiquitous computing. Just like extreme programming, here we say stories are says Scrum, and we calculate the backlog. Suppose out of 100, 80 Scrum would be cleared and 20s are left, then backlog would be 20. And sprints, stories and sprints, they are same thing, and the number of meetings, here the conceptual things are introduced. Instead of one meeting, 2 meetings are done. Instead of written communication, the verbal communications are recorded and they are given more emphasis. The team interaction is increased, and likewise the scrums are cleared or through the scrum meeting and through the backlog clearance techniques. So, in summary, we can say that the Mark Weiser in 1988, that is the father of ubiquitous computing, started the third paradigm of computation, and he introduced the advanced computing concepts, whether the computing is made appear everywhere and anywhere, and it is near to pervasive computing as well as near to mobile computing, and the world has shifted from the area of content to the area of context. Earlier, in the earlier software development, the content was very, very important, but these days the context is very, very important. And you change the context will have to be changed. So, context is little bit inferior. Though there are many government projects and the private projects in India, they are ubiquitous. For example, UAgree, that is CDAC projects, CDAC Hyderabad, and that is a ubiquitous projects, and Genesis, that is again a very good projects by the CDAC Bangalore, Linux kernel programming plugin, Shoot, and that is a very good project for the CDAC, state of art test bed for advanced research in multimedia over IP, that is taken up by the CDAC Hyderabad. Similarly, YSNIDE, that is wireless sensor network integrated development environment by the CDAC, and the mother mobile based maternal health awareness system, that is implemented by CDAC. Spark, small parking, that is taken up by the Amrita University. All these are the ubiquitous software projects. Pollution monitoring and evaluation system, that has been taken by IIM Kolkata, they are the running projects. And wireless sensor network for the real time landslide monitoring, that is another projects. Development of multimedia user interface, that has been taken by IIT Kharagpur. Then the NCM RWF, National Center for Multimedia Range Weather Forecasting Center, and that has been initiated and implemented by CDAC Pune. So, ubiquitous computing will lead to ubiquitous computing will lead to ubiquitous commerce, means the right message will reach to right person at the right time. So, the impact on the business would be more awareness, more accessibility and the more responsiveness. Okay. Ubiquitous computing will lead to ubiquitous commerce, means right message to the right person at the right time. So, there would be heavy impact on the business strategy, the awareness in the business community will increase and the responsiveness will increase and the accessibility will increase, and which is a very good, which are the very essential parameters of the business, and through ubiquitous computation these can be achieved very easily. So, the change in the nature of service provider, service level commitments will increase and new services will arise. So, the user experience, balance user perception of complexity, it will increase the efficiency, effectiveness, interaction, etc. So, it will achieve the high network effect, role of the context, user experience, and the challenges would be internet access, of course, the available memory of the personal devices, because there are many devices are being used, their memories are limited and they are supposed to be adaptable. So, that is a big challenge. Seamless access across the network and online and the offline interchangeability. So, there are some impact on the social issues also. So, the potential detrimental management behavior is needed. So, the log tracking, non-guidance, they are essential. Work can occur anytime, anywhere, because of the nature of the ubiquitous computation, and they must study the behavior and adaptation to ubiquitous computing at the individual level, virtual team, and at the organization level. So, the fundamentals of the UC is conceptual quality models, pervasive environment, ubiquitous environment, and the system models. There are many system models. The conceptual quality models, because the most popular quality models in the area of software engineering and the computer science is the McCall's quality factors, and all the softwares and the system designs are being checked on these quality factors like maintainability, flexibility, testability, portability, reusability, interoperability, correctness, reliability, efficiency, integrity, usability, and they can come under the product revision, product transition, and the product operations. So, all these McCall quality factors, they can be directly measured, they are metrics also, they can be measured also, and they can be used in the computation of the higher order metrics. But in the area of ubiquitous computation, because the high mobility and the high embeddedness is needed, so these quality factors alone are not sufficient, and that is why we say conceptual quality models are needed. Apart from these quality attributes, there are many attributes which are essential in the area of ubiquitous computation. Those should be found out, those should be tracked, and they should be quantified to find out the ubiquity of the system. Ubiquity means a one perception of the ubiquitous model, which will talk about the mobility, embeddedness, invisibility of the system. So, there are many models which has been suggested for the case of ubiquitous computation. and I have taken few of them. So, for example, Sensei, it is the ubiquitous system models, and it is a context aware mobile phone that adapts to dynamically changing environment, and this is the suggested models. There are 3 parts of that, and this model can be directly implemented to give the high level of ubiquity. And another architecture or the design which has been suggested is middleware architecture. It is known as Home ROS, and here there are 3 level of design. On the first level, we have the core component management. Core component management means many components are being created and they are kept freely for the uses, and after uses they are kept in the library. Then the event manager come into picture. Event manager, according to the event, they choose the component, and if the event is finished, they put the component in the repository. Then we have the component repository. They are repository or the racks of the components from where you can pick up the components and use it, and you can repository the components after the uses. Then we have different small systems, for example, context manager, quality of services adaptation, configuration manager, resource manager, and security manager. So, UbiCom applications are supported by sophisticated middleware components enabling dynamic discovery, invocation, and the management of resources. So, this model is extensively used for the ubiquitous system design and the software development. So, you create the components, keep the repository of components, use the event management techniques to use the components, and after uses keep it in the repositories. Then you have different fragmented portion of software in the form of context manager, quality of services, configuration manager, resource manager, security manager, etc. We have other system models also, which are in the form of multi-agent system models, etc. So, now we will talk about the essential. There are many measurements for showing the ubiquity of the software projects. Now we know what the ubiquity is all about. Ubiquity means for any system design, if the ubiquity should be 100%. If the ubiquity is 100%, it means the system is highly mobile and it is highly embedded. Means any embedded devices can be used. If the devices are highly embedded, means user is unaware of all the devices. User is simply using the device, and there are many computers are being used, but user is not aware of that, and user is getting the result according to his choice or her choice. So, there are many parameters which can be directly measured, and there are many parameters which can be directly used for the computation of higher matrices. So, I have tracked down some of the measurement which will directly reflect or which will directly talk about the ubiquity of the ubiquitous computation environment or the software. The first of them is service omnipresence, means it is desired that whatever service the system is giving, that should be given everywhere. Whether you are at this particular instant of time, a user is in Delhi, and immediately if he after 8 hours he is in other country, he or she should be able to get the same service. That is called the service omnipresence. A ubiquitous system should be able to do that. It should be invisible. Invisible means if you are connected with 10 devices, your computation is connected with 10 devices, all the devices should be invisible. For example, if I am operating the Hong Kong bank from this place, so there are so many devices or computers or networks are in use, but I am using only my smartphone. So, all the devices are invisible to me, that is called invisibility. Then context sensitivity. Context sensitivity means the devices should be able to sensitive to capture the context information. For example, if dust sensor is being used, it should be immediately captured the changes in the dust percentage. If humid sensor is being used, immediately any changes should be recorded. If temperature sensor should be used, means any devices, because in the ubiquitous computations all the devices should be sensitive. If any changes occurs, it should be immediately captured. Then the adaptable behavior, it is a very good measurement or it is a very good criteria. Means if some changes are needed, suppose the new sensors came in the market, then your design needs that new sensors, then it should be immediately adapted in the system without zero delay. With the introduction of the any device in the system should not get disturbed. Other testings should not required. That is called the adaptable behavior. And on the daily basis, the devices can be changed in the system and it will not hamper. It was not possible. It is not possible even in the case of mobile computation or in the embedded computation. If any changes are done at any level, it trigger the system itself. Then experience capture. As experience capture means intelligence of the system should be increased. Based on the experience, all the experiences should be captured by the system and it is recorded and it should be passed to the higher to gain the higher experience. That is called the experience capture. Any experience in the network or in the system should be captured and it should be utilized for having the higher experience. Then the service discovery means what are the new services possible, it should be discovered. Suppose any ubiquitous system is being used for 10 services, but there can be 100 services rest which can be used, that is called the service discovery. And then function composition. Function composition, right now the any system is used for 10 functions, it should be increased from 10 to 100. That is, what is the function composition right now? Suppose there should be 100 function composition, but system is being used for 10 only, then it is 10% only. Then spontaneous interoperability. Spontaneous interoperability means suppose a system is changed from one place to another place, then there are so many devices, so many networks which are new to the systems. So it should be operable in that environment also. And heterogeneity of devices, because there are many types of devices worldwide, so it should be able to induct or capture the heterogeneous devices, and that percentage is a must. Then the fault tolerance means system should be able to tolerate the fault. Even if some fault comes, it should be able to capture it and it should be able to re-diagnose it. That is called the fault tolerance. Fault tolerance means if a system is undergone through some fault, it should not hamper the whole system, it should tolerate that fault. And then privacy. Privacy and the security, that the most important issue, because we are making the system pervasive, ubiquitous, mobile, it can be operated from anywhere, everywhere. So it has a high impact on the privacy. So the privacy and the security part should be of high quality, because it cannot be compromised. You cannot make the system ubiquitous, pervasive or the mobile with a compromise to the security and the privacy. So we have done some case study on a system that is called Japper D, and to check the ubiquity of that system. So here is the system Japper D architecture. This is the architecture. The APK is the mobile phone application. From mobile phone, the Japper system is being used, and the internet and the intranet zone has been used, and these are the spreadsheets which have captured many information. We will take up one by one the every matrix of the ubiquitous computations and we will calculate the percentage measurement of every criteria. So the first was the service omnipresence. So for that Japper D, it is being used the operation on which software is configured / the operation on which software can be configured. This is the definition. So right now this Japper is being used on Android or iOS based mobile or tablet or the iPad, and in the future it can be used on Android, iOS based mobile or the tablet or the iPad and Windows 8 and the BlackBerry mobiles. Means right now this Japper is not being used on the Windows 8 and the BlackBerry mobile. So 4 by 6, it is 0.66 means 66%. So service omnipresence for the Japper D is 66% because out of 6 it is being used on the 4 services. So it is 66%. Now let us take the context sensitivity. The context sensitivity talks about the available context sensitivity divided by overall context sensitivity. So this particular Japper is able to capture the location right now, it is able to capture the thumb impression, it is able to capture the signature. Means this is able to capture the 3 context information. So that wise in the numerator it is 3, and it is desired that it should be able to capture the face recognition, it should be able to sense the user surrounding environment, it should be able to capture the signature also apart from the thumb impression and the location. So basically right now this particular Japper is context sensitive on the 3 items or the environments, and the overall context sensitivity desired is 6. So the context sensitivity measurement is 50%. Similarly, adaptable behavior for this particular network or the system is, it can be defined as service currently adaptable oblique services which can be adapted. So right now it is adaptable on Wi-Fi printer, GRPS, 2G and 3G. So the service adaptable is 4, and it is desired that apart from this it should be able to adaptable in 4G environment also. So of course 4x5 on 4 items or the 4 environments it is adaptable, and the 5th it has to be made adaptable. So the adaptable behavior is 80%. Similarly, service discovery can be defined by services are in use divided by total service discovered. So right now this Japper is being used in the banking and the insurance sector. So the service is used in is 2, and the service discovery, it is desirable that apart from the banking and the insurance sector, it can be used in the logistic and the transportation sector. They are same. So the total service discovered is 3. With the little bit fine tune in the software on the system, it can be directly used in the transportation system and the logistics system. So the service discovery is 67%. Similarly, function composition, it can be defined as services available to user divided by total services which can be made available. This is 1 by 3. So this is being used in finance sector right now, this Japper, but it can be used in other sectors also. So that can be 3 has been taken. This function composition can be extended. So 1 by 3, it is 33%. Similarly, heterogeneity of devices, from the spreadsheet we are referring for the mobile capture server, for the integrated adapter, for the mobile capture client. The tested devices are 11 by 28, it is 39%, and supported devices it is 94%. Similarly, we have integration adapter for the tested devices are 48% and supported devices are 95%. So for mobile capturing client, the tested devices are 100% and the supported devices are 100%. So no updation is required. So here we have quantified the metrics by calculating the service omnipresence is 45%. It needs to be increased because in this particular Japper which has been taken for case study, the service omnipresence is 45%, which is very low. For this system to be ubiquitous, it should be 90%, almost 90%. And the invisibility is 1 means present. All the devices are almost invisible, good. It is a good criteria. Then CS is 25%, it should be on the higher end. Adaptable behavior is 80%, good, it needs further increased, and EC that composition is not present right now, but it should be present. Experience capture should be present. Right now the system is not able to capture the experience, not able to utilize the experience further. So, but this is a very good criteria of the ubiquitous computing. In the further version it must be present. This is the lacuna of this particular Japper right now. The service discovery is 67%, means it is able to discover the 67% new services apart from the services where it is being used. And similarly, heterogeneity of devices are more or less good. Fault tolerance is high, it should be made more high, means the system is fault tolerable, like that. So, similarly, the case study shows the comparative data between the two versions, and you can clearly see the SO in the old version was 22% and it has been made 60% in the new version. A great achievement. Invisibility was low earlier, the invisibility is very high. In CS it was 33%, which has been increased to 50%. Adaptable behavior was 50%, now it is 66%. And EC was present earlier also, and it is present in this version also. And service discovery was 67%, it is same in the new version also. And function composition was not present earlier, it is present, and the quantification is 33%. Similarly, the service integration was not present, it is present in the current version, and the heterogeneity of devices has been updated, and fault tolerance of it has to be high. And so, similarly, the other case study for a university, and it has done on the open source product, and Uni LRL 1.9 currently being used, and the new version for which the testing has been done is Uni LRL 2.7, which will be used from the next January. This is the QOC context, quality of context aware applications, and the framework is usability evaluation framework has been used, and which talks about the usability of the ubiquitous computation framework. And here this records has been captured: service omnipresence, invisibility, CS, adaptable behavior, experience capture, service discovery, function composition, service integration, and the HD, fault tolerance, and the present. Some of the design pages, and which talks about the ubiquity of the computations. As we talked of, these design pages has been made, and which talks about the availability, usability. These are the MAC calls parameters, basic parameters: integrity, conceptuality, context sensitivity, and this parameters has been taken individually to calculate the ubiquity of the software project or the system design or the system software. So, these 4 projects has been taken up to, and the many information has been captured to make the comparative decisions. So, the project taken up are reactive room, this is a software in the ubiquitous environment; cyber guide projects, smart home application which is highly ubiquitous, all the smart home applications are ubiquitous. Then the kids room application are ubiquitous, responsive office, and the edge cap which is used for call forwarding, etc. And the context types are active, A for active, I for identity, L for location, T for time, and the context awareness is P for present, E for and T for time, E for elective. So, all the among all these projects, The context type information and the context awareness informations has been compared in the form of present or absent. The present is recorded as 1 and absent is recorded at 0, and that is quantified. So, you can clearly see for the reactive room application, which is defining the intelligent control of individuals. So, that is 25%. Percentage type of the context type is 25%, and the context awareness is 33.3%. For the cyber guide projects, which is used as a tour guide, the context type is 75, which is very good, and the context awareness is 66.66%. For a smart home application, or the context type is 25%, which is very low. It needs to be increased, and the awareness is 33%, 33.33%. For the kids room, the context type is 50% and the awareness is 0, means a lot of technological changes and the environmental changes has to be made to make it some quantified value. For responsive office, the context type is 50% and the context awareness is 66.6%. For the edge cap, which is used for call forwarding, the context type is 75% and the context awareness is 33.33%. Now, by taking the ubiquitous parameters, those were the context type parameters and the context aware parameters, which are the basic parameters to be used in the features of the ubiquitous computations. Now, all the projects, reactive room, cyber guide, smart home, kids room, responsive office, has been checked on the basis of the basic characteristic of the ubiquitous computation. For example, service omnipresence, adaptable behavior, experience capture, service discovery, service integration, function composition, and the inverse. And for reactive room, the average ubiquitous characteristic present is 71.4%, cyber guide is 71.4%, smart home is 71.4%, kids room is 42.8%, responsive office is 42.8%. So, a framework needs to be designed. A framework has been designed where all these projects data has been captured, and this framework talks about the relative ubiquity of the many projects. So, ubiquity gives you one matrix which talks about how much your system is mobile or how much your system is embedded, and the percentage of ubiquity will talk about that. So, there will be no confusion amongst the customers. The customers, they are not technically competent, so they will simply judge your projects or the system by looking at the ubiquity value. So, a lot of things are needed in this particular area, because even this area is in the nasty phase and a lot of research has to be taken up. So, more applications are there where the case study can be done in the area of home application, smart alert application, etc. that is required. So, this I have suggested this format where you can define many rules by taking context awarenesses devices and the data transfer the picture, and this model should be able to give the ubiquity level for any system or any projects, so that there should not be any confusion among the users or the application orienter. So, the summary is the unlimited access should be done from anywhere, from any place and from any organization, and any technology which is coming in the market, that should be immediately incorporated in the system or in the design or in the software. And it can be used in the cognitive model, in the interface model, and in the contextual awareness model, and the adaptation to the task can be performed. So the new businesses and the new framework must be designed in the area of ubiquitous computation. So the design documents, the coding phenomenon and the testing phase has to be in line with the ubiquitous computation. So as well as with it should match with the business requirement and the business delivery.
Friends, due to paucity of time, we have to stop our lecture here. On that note, we would like to thank Mr. Mishra for coming to our show and delivering this wonderful lecture. And thank you, dear friends, for watching our show. Stay tuned and keep watching. Thank you.